So hello everyone, welcome to our first video in which we are going to discuss about the books that you can use to start and learn finite element method on your own. So to make things simple, I have categorized and selected the book in ascending order of complexity. So I have done the categorization as beginner, intermediate and advanced. So the beginners will include the books which include little bit of the mathematics and also gives you a practical exposure towards the problem that you are going to solve. In intermediate level, there will be some calculus and the variational approach, and also you will find the detailed explanation of the theory that we had covered in the books of the beginner section. Finally, there is an advanced section. So advanced section is like when you already have some experience with the finite element method and you want to jump into non-linearity, or you want to uh, code your own problems using MATLAB or other tools. So for those things, and also into the complete insight of the FEM, like what is internally going in the FEM. So there are some tensors and other things that will be required. So that's why I have kept those books in the advanced category. So let's start. First thing first, these books are not like given by any of the experts or something like that. These books are based upon my practical exposure of around 6 years of working on the finite element method. So here you can see that on the left I have mentioned 3 books. So all the books are something based upon the practical approaches, like what if it deals with the mathematics, at the same time it also explains like practically what is going behind those mathematics. So first book is Finite Element Method, a practical approach. So it's a very good and written book in which it's written in a very simple language. So I will recommend starting with this book. Then we have Practical Finite Element Analysis. So this is something that is based upon industrial perspective. So this will also give you like in industry how people are using the finite element method. Then Practical Stress Analysis with Finite Element Method. This is also a very good book. If you are referring the top 2 books, that will be enough, but I will recommend going for the third book also. Now on right hand side, you can see that I have mentioned 2 more books. First, Course in Finite Element Method. So that will be a must book. That's why I have kept the image of the book. So that will be a must book. In addition to that, I have also given one more book name, that is Finite Element Method Theory and Application with ANSYS. We know that ANSYS is a leading simulation tool in the market right now. So that's why I have kept the ANSYS. You can also start with the other tools like Abacus, SolidWorks, and there are many other tools available in the market. So this book is a very good collection of the theory. At the same time, it gives you chance to solve the problem and implement those things in the ANSYS. So it will be a very good exposure for you. Like at the same time, if you are reading some theory, you can also implement those things in a tool and see what is happening. And also you can go through the documentation to understand these things in a better way. Like each tool comes with a documentation. So when you are dealing with any tool, it's good always to keep those documentations with you, so that if they are applying some type of boundary conditions, like in some software the boundary condition name will be different from other softwares, so it will be good to keep those boundary conditions, but the mathematically you will understand like what that boundary condition is doing. Like suppose if we take an example of a fixed constraint. So fixed constraint, what it is doing is that for a 3D problem, it will restrict the translational degree of freedom u, v and w. But if you go for the beam formulation, what will happen is that it also have to restrict the rotational degree of freedom. So these things you will understand when you are keeping a mathematics and practical things side by side. Okay, so now when you go through all those these books, then you can go to the intermediate level, and I am pretty sure you will have a very good insight about the FEM by this point. Now it's time to understand the complexity and mathematics used to derive FEM. The books mentioned here are a little bit mathematical, but they have done a very good job in keeping things simple. So that I have not kept this book in the advanced section. So here you can see that I will recommend to start with Concept and Application of Finite Element Method and Finite Element Method by J. N. Reddy. So these books will be a must for you if you want to further extend your horizon into the FEM world. Now on right you can see there are 3 books. I will recommend using this finite element procedure. This is a very good book. It is like a Bible for finite element procedures but it directly jumps into Lagrangian and other formulations. So maybe you will find it difficult to understand it. So that's why I will recommend, means when you are done with concepts finite element method, then you can go with for the finite element procedures. And the favorite book on this slide for personally for me is Finite Element Analysis from Concepts to Application by David S. Burnett. So this book is costly, so and you will find this book in the libraries only. So I got a chance to go through this book when I was in IIT, but if any of your friend is already in IIT, you can ask for them to provide you some Xerox or any other things. Otherwise, this is the, I think on this slide, even I prefer it, I rate it better than Robert Duke Cook on my personal level. But usually people prefer Cook book better than any other book for the intermediate level. Now let's go to the final slide. So this is something that 3 books I have mentioned. So first of all, Introduction to Nonlinear Finite Element Analysis, Nam Ho Kim. So this book is very well written, keeping in mind the other things related to the nonlinearity. So it starts with a very simple language. Means if you are dealing with the contact, they will take a very simple example of 2 beams coming in contact with each other, or the frictional cases. Or if you are going to the material nonlinearity like plasticity, hyperelasticity and other things, the formulations are kept in a very simple manner. So you will understand these things unless and until directly jumping into the very hectic tensorial formulations of the same problem. But if you are going for a programmatical approach, like you want to actually program your code, so for those things, Nonlinear Finite Element for Continua and Structures is a very good book. It gives you a completely insight like how tools implement any type of formulations. Like if you take a case of plasticity, so in plasticity, to implement the plasticity, there are different ways like isotropic hardening, kinematic hardening, multilinear hardening. So it also gives you a code. So you will understand the algorithm that is internally used by the tools. Now, the Finite Element Method for Solid and Structural Mechanics by Jinkovic, this is again the Bible. Means nobody has explained finite element method in a better way than Jinkovic, and he is well renowned means person. Everybody means if you talk to any of the people who are working with the finite element method, they will directly tell you about this book, but they will not tell you that this is something that is a very advanced. If you directly start with this book, maybe you will not like the beauty of the FEM. So that's why means usually what people do is that if you are starting at a bachelor's level, try to learn the finite element method. You will end up giving up on this book, and you will again start searching another book like which will explain the things in an easy way. So finally, if you are means after completing all those books and going through the any tool like ANSYS, then if you take this book and read it again, you will think that yeah, this is the book that actually talks about the finite element method. But if you directly jump to this book, you will say what the hell is this? Means you will not able to understand the things. Means on a personal level, I have to start with this book only because I got a means it was mentioned as a coursework. So I have to anyhow read this book only, and I have taken another sources and the helps of the notes of the other peoples to learn FEM. So that's all. Means so I will ask you to means if you like this video, please like and subscribe our channel, because we are continuously going to put more videos on the finite element method. See, this is our first video, so I thought of giving you a brief insight about the books that will be required if you are starting with the finite element method, and if you are in a mechanical, aerospace or civil engineering background. If you are in electrical, heat transfer fluids, if you want to do those type of simulations, there are other types of books. If you are interested, means because I got a chance to work in a multi physics field, so I have a brief understanding of the good books that are available in the market to handle those type of problems like electrically coupled structural problems, or if you talk about the chemical engineering or electrical technology or heat transfer phenomena. Even for fluids, some tools still use finite element method approach. So that's a very big discussion. So we will not go into that, why they are still using finite element method instead of finite volume method, which is very fast. So that's all. Please subscribe the channel. We are going to slowly discuss about all the finite element approaches, and at least you have an idea like which books I am going to refer in order to explain the things. That's all for this video. Thank you. Let's meet in our next video. Thanks.